all, we often hear in the news about national leaders making bigger delegations, and even small kids are protesting Fridays for Future and so on, just for climate change. So, is it something to be taken very lightly? And global warming is the main cause for climate change, as shown here, but global warming is due to greenhouse gas emissions, and you might be wondering, yes, global warming is due to greenhouse gases, and greenhouse gases are very bad, but I don't think so. So you can question yourself, are greenhouse gases really bad? And my answer would be no. Why is it so? They are very important for us to survive. Yes, they are very important, greenhouse gases. And to judge myself or to justify this statement, we must go through first basic question of how atmosphere evolved. And you might be wondering why this question is here. Like when you step out or you step into a car parked outside, you feel much hotter than your surroundings. So what this random question here? No, these are all interlinked. So now let us discuss about how atmosphere actually evolved. Primitively there was so-called a very big mass of gas. Okay, this is in gas form. You will be having many particles of varying sizes, but this was not any ideal. To be frank, exactly in this whole cosmos or so-called big universe, actually there was something called supernova, a star or some small entity which exploded or created something called Big Bang stuff. Okay, so it burst out into a big mass of gas that it had so many particles, dust particles obviously. So it was not anything like ideal, it was just rotating over itself. So as it rotates, basic physics where we have the centripetal force, and also yes, the particles got concentrated and the size of this nebula got decreased, so it turned into somewhat like a liquid molten form. Okay, liquid molten form. And here further again, it got heavily concentrated at the core, like nickel and ferrum. These are heavy metals, so they got concentrated at the core, whereas the lighter metals like aluminum, silicon, manganese, as such, they remained at the topper surface. Okay, so heavy means iron, ferrum, nickel, and heavy metals as such got concentrated in the middle. So this turned into solid. It's like evolution of earth, to be frank. So this formed the core of the earth, and this formed the crust of the earth, and something like liquid entity is there which is called the magma. Okay, so sun is impacting whatever the planets that got formed. Similarly here also earth got impacted by the sun's hot spot radiations like solar winds and all. So the solar spots washed away this primitive atmosphere which is somewhat formed above here. So the primitive atmosphere got lost because earth is somewhat nearer to the sun. You will be having like Mercury, Venus, Mars, Earth. These are called inner planets. So these do have a rocky surface on them. These do have lithosphere. Crust surface is there, and the atmosphere. Atmos means actually meant by vapor. Okay, it does have some sort of atmosphere which is held by gravity, but unlike that, we have the rest like the Jupiter, Saturn, Neptune, Pluto. Like these are outer planets. Okay, but whatever the planets that are after the earth, the remaining 4 planets are called outer planets, but these are gaseous in form. So if you try to land on Jupiter, it's quite impossible because it's all gaseous surface. Because just like I said, this is how any planet had evolved, but the outer planets didn't have that impact of solar winds, so they remained in gaseous form, whereas the inner planets, Mercury, Venus, Mars, Earth, got impacted, or the primitive atmosphere that got formed is rubbed away by the impact of solar hot winds. So it had this lithosphere structure, and some sort of atmosphere is still left due to the gravity. Okay, due to the gravity of Earth. So what comprised of this atmosphere? Obviously CO2, water vapor, and some dust particles or methane, whatever it may be. Okay, so our atmosphere is comprised of these entities, like something like particles, dust particles, gases and all. So now we will talk about what is this relation between greenhouse gases and these normal atmospheric particles, but there lies the answer. Okay, so we obviously feel that greenhouse gases are bad because they are causing global warming, and it is leading to climate change. So no CO2 at all, no CO2 at all. No, this is wrong. CO2 must be there, and CO2 is what is helping us to survive. Our earth is such a gigantic ball. To be frank, it is rotating around itself and also revolving around the sun. Without atmosphere, can you imagine how our earth would look like? It would be so hot in the day and so cool in the night because of the atmosphere is absent. So there won't be any sort of optimum temperature maintained. Because of the presence of the atmosphere like CO2 gases, water vapor and all, we are keeping the earth's temperature optimum such that we feel warmth, or else the daylight would be so hot that you can't survive at all, and the night will be so cold that even that extremes also you can't survive. So atmosphere is important. So how exactly CO2 water vapor contributes to keeping our climates cool or optimum? Because for example, if you observe what exactly is meant by greenhouse gas, why the term origined? Suppose when you go to some Arctic region or to cold places, you will find crops are being grown inside a glass entity form of a room like that, because there the temperatures are quite low. So whatever the heat received, they want to sustain that heat for long. So gas is such a good component where it keeps all the heat gathered optimally. Okay, so that's why it is called greenhouse. Glass door is there, glass, and here you have all the crops grown. This is all glass entity. So these are the sun rays. Okay, so glass door, it receives the solar insolation. Okay, and it lets out, and it lets in the solar insolation, solar rays penetrate into it, and every body has this tendency to emit out whatever it is received. There is this tendency to emit out. So even the small entities here, whatever that are present, they tend to emit out the radiation. But glass doesn't allow the penetration, or it just blocks or traps. So there won't be any outlet or radiation emitting out. The similar way CO2 also functions, water vapor also functions, and methane is also a greenhouse gas which is often ignored, but do you know that it is 80 times more potent than carbon dioxide in trapping the heat? Because of this heat trapping nature of the various atmospheric particles, we are feeling that warmth around us. Imagine without the presence of carbon dioxide, water vapor or methane or whatever other gases or atmospheric particles, you won't feel like optimally living conditions. Okay, it will be too hot because directly the sun rays will be penetrated, and earth becomes too hot, and whatever it received, it is emitted out, because it is the natural principle of any body to emit out whatever it received. So the radiation will be so long that it just completely gets too cold. So it's not worthy enough to discuss our surviving conditions without atmosphere. So these particles are very important, but that doesn't mean that I am against this greenhouse gases, like I'm against this global warming concept at all. But yes, if these CO2, water vapor, whatever released, if these are in optimum conditions, or methane, it's nothing but natural gas, or chlorofluorocarbons, these are completely banished in the Montreal Protocol. So no, now these are not being emitted out, because our national leaders have delegated in the Montreal Protocol to ban completely, because these are carcinogenic. But however, whatever the remaining stuff is there, CO2 is also good, and I have just proven it. CO2 is good because it is good in trapping the heat and maintaining the optimum temperature for our survival. But yet these are being disputed to reduce our CO2. For suppose in this recently held COP26 summit in Glasgow, Switzerland, Scotland. Okay, there was this delegation among the national leaders to phase out carbon dioxide completely from the environment. But India, China, they said we will start our emissions to get reduced from 2070 onwards. So net zero by 2070. Net zero in the sense, whatever the carbon we are emitting out, that is to be absorbed by the forest. Okay, so here net zero doesn't mean we are making zero carbon emissions. Okay, it's not zero. We are making CO2 emissions, but whatever the emissions are done, that are to be exactly sucked in by the forests or some other techniques, using some other techniques, or using renewable energy sources, or recycle as such. By these measures, whatever the carbon dioxide that is released out, or methane for suppose, or water vapor content, okay, exactly, it is a long-lived emission, greenhouse gas, long-lived. CO2 is long-lived greenhouse gas emission, whereas methane is short-lived. But CH4 is 80 times more potent than CO2 in trapping the heat. So whatever it is emitted out, it must be received by the forest and all. So that's why it is said to start reducing your CO2 emissions right now itself, such that by 2050 globally we can say there is neutrality in CO2 emissions, and there won't be much climate change. So we are tending to reduce the CO2 released, because there is this imbalance created. Actually, whenever CO2 is released, it must be balanced. For suppose plants are there, I know that you are aware about this photosynthesis process and all. Plants require CO2 for its photosynthesis process, so they absorb CO2, whereas humans, animals, they release out CO2 and absorb oxygen, whereas plants, they absorb CO2 and release oxygen. Okay, so if this is balanced, then there need not be any dispute over greenhouse gas emissions and all, like more CO2 is being emitted, but this is not balanced. CO2 is being released more due to the burning of fossil fuels, so this is quite disturbing, and this is too much. Most of the emissions out from the smoke and all, this is only CO2 or the fly ash or the carbon content, that plants are less in our environment, and CO2 is being just floating on our atmosphere. Okay, considering this as Earth, on our atmosphere CO2 particles are just flowing, so it takes up the solar radiation, which is short wave. It's a part of science, so short wave solar radiation, and it just allows the short wave solar radiation to penetrate. But as I said, Earth, whatever it may be, the body, it radiates out whatever it receives, so it just releases out long wave terrestrial radiation. Again, CO2 absorbs short wave radiation, it penetrates it, and the Earth releases out long wave terrestrial radiation, and it is getting trapped in the atmosphere. Okay, so to be frank, this is like it is getting trapped. This is like a troposphere. Troposphere is up to 13 kilometers in space. So up to 13 kilometers, convection takes place. Okay, and above it is a stratosphere, which is up to 50 kilometers, where conduction takes place. I will just make this picture further clear. So let me tell you why greenhouse gases are required, and they are good to maintain optimum temperature for our survival on the earth without extreme cold temperatures in the night or extreme hot temperatures in the day. But they are also dangerous if they are excessive in nature, like resulted from the burning of fossil fuels that may cause a greenhouse gas effect like global warming and climate change. So on the earth there are different layers of atmosphere, right? In the figure as you are seeing, there is a troposphere, stratosphere, and up to the level of 13 kilometers it is our atmosphere, simply called as troposphere, and above it is the stratosphere, where conduction usually takes place, and above it is mesosphere up to 80 kilometers, and then thermosphere up to 400 kilometers, and right around the rest is exosphere, where usually inert gases like hydrogen, helium, they usually take float there. And this is the solar insolation. Whatever the solar rays are coming, they are in different forms and different wavelengths. For example, if you observe, the X-rays and radio waves are usually found in the thermosphere or ionosphere, where satellites do work for communication purpose, and meteors, meteorites, as they are nothing but the shooting stars, they are usually present in the mesosphere. And UV rays, the part of the sun rays, some are called as UV rays. They are usually present in the stratosphere, and these are obstructed by the ozone layer. That's why we are getting protected from the UV rays. And yes, a part of solar insolation also consists of infrared and visible light. Visible light in the sense we feel it in the form of visibility. We are able to see the things now, so that is due to the presence of visible light radiations from the sun rays. And then infrared, that is not actually visible to us, but infrared rays means we can feel that presence of infrared rays in the incoming solar radiation. This is due to the tanning we get, or the solar tan or sunstroke as such we can say. So these are different parts of the solar radiation. You see that our atmosphere is quite well protected due to the presence of the atmospheric particles like CO2, clouds, water vapor, methane gases and all. They are important, but extremes of them is not good for us. So how they are important? They are optimally required to keep our temperature good. So these particles, they absorb the solar insolation, so they let in the short wave solar radiation. They penetrate, so the solar waves penetrate into the clouds or CO2 particles or water vapor particles, and they just penetrate it. That means it is like permeable membrane. They act like permeable membrane, to be frank. So it is quite impregnable that they all enter through it easily and they hit the earth's surface. So as I said, any body that receives radiation, it ejects out in the form of re-radiation. So here it is called as a long wave, in the form of long wave terrestrial radiation, which is shown in pink color. So yes, it ejected out. Some part of it is left back to the space, but most of it is ejected out. So when it is ejected out, the carbon dioxide particles again, they absorb it, but this time they simply absorb, but they won't let it go outside. That is the nature of the carbon dioxide gas or water vapor particles. Especially we will discuss here about CO2 emissions. So whatever the CO2 is present here, they usually absorb it and keep the heat or trap the heat of the radiation emitted by the earth. So yes, that's why our atmospheric particles over here, which are held by gravity closer to the earth's surface, also take up this warmthness. So they make us feel warmth during the daytime, and of course the re-radiation goes on happening till again it receives the sunlight in the next morning. So at the night time it becomes completely cool, such that it is also optimum for us to survive. Okay, but now the problem is, usually if it is balanced with the plants absorbing O2 and releasing CO2, it is quite okay. But sometimes there is imbalance created due to the excessive burning of fossil fuels, where we are having large number of CO2 emissions, and these are really forming like a huge heavy cloud over here. So the radiation, the Earth's re-radiation, long-wave terrestrial radiation, is not being released back into the space, but they are getting intensely trapped over here like a blanket of CO2 gas. Molecules are trapping the heat completely, and it is not getting it let out. If there are less number of molecules, then the CO2 molecules trap less amount of heat, and that is quite optimum for us to survive. But due to the presence of high and heavy number of carbon dioxide molecules in the form of big blanket, everything is being absorbed continuously, and that's why there is this phenomenon of global warming. Similar phenomenon is also observed in case of glass doors, which I have discussed, like why you feel the interior of the car very hot when you step into the car rather than the surrounding atmosphere. So here what happens is, let's assume this is the glass and this is a car. So here is the solar insolation. The sun rays come and fall onto the glass. Glass has this tendency to penetrate into it, the solar insolation, and it enters, but then it heats all the different parts like plastic seat covers, seat belts, and whatever the gear rods, etc. All the parts of the car get heated, and then it emits out radiation. So any entity, any body, unlike similar to the earth, any body, it may be whatever the body, it receives any radiation, it has the tendency to emit out that radiation. So here also the glass, window panes, car seat belt, etc., they tend to emit out the received radiation. But here the glass obstructs the ejection of that radiation. That means it It takes the input of the radiation, but it doesn't let out the radiation emitted by different parts of the car, so we feel intense heat. Similar is the phenomenon used in the greenhouse gas effect while growing crops in cold Arctic regions and all. So that's why it is called as greenhouse gas emission, and these are quite required for optimal maintenance of the temperature for our survival, but excessive liberation of such gases is quite harmful. Especially methane is 80 times more potent than CO2 in trapping the heat. And of course here I would like to talk to you about one more thing, like are you aware that we should not sleep under the trees during night time? It is often said so. Why is it so? Yes, because usually plants also respire. Plants do use carbon dioxide and also even oxygen. A part of oxygen is for inhalation, just like humans, animals. Plants also take oxygen, but during daytime they utilize carbon dioxide. So they use carbon dioxide for the process of photosynthesis. But apart from this photosynthesis process, plants do use oxygen for intake in respiration. They inhale oxygen and they release carbon dioxide. They exhale carbon dioxide. Similar to humans, animals, plants also inhale oxygen and exhale carbon dioxide. But during daytime, photosynthesis is done, so carbon dioxide is usually taken in more. But in the night time there is no sunlight, so there won't be any photosynthesis taking place, but usual plant respiration happens as usual. So it intakes oxygen and releases out carbon dioxide, and there is no this phenomenon of photosynthesis. So now if you sleep under the trees, the usual process of inhaling and exhaling takes place. So carbon dioxide, whatever it is released by the plants, is no more utilized by them for photosynthesis process. So the carbon dioxide floats over there, and that suffocates us if we sleep just below the trees. So that's why it is said not to sleep under the trees, not like any ghosts and all. I think now you got cleared about these concepts.